The eruption itself lasted only a few violent hours, but the danger stretched on for more than a century, starting the moment this island tore itself apart on August 27, 1883. And that first collapse was just the opening scene. Over the following decades, scientists watched a brand new cone claw its way up out of the drowned caldera, piece by piece, eruption by eruption, rebuilding a mountain that history had already tried to erase. By the time we're done here, you'll understand exactly what monitoring stations in the Sunda Strait are picking up right now, and why Indonesian volcanologists just moved this mountain to a level 3 alert. Today, we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally felt an earthquake, watched a volcano erupt, or lived through a disaster warning? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one, so the algorithm actually shows it to people who need to see it. Now, let us get into it. To understand why one small island in the Sunda Strait keeps American and European seismologists up at night, you have to go back to the mountain that used to stand there. Krakatoa was not always a memory. Before 1883, it was a real, solid island between Java and Sumatra, tall enough to be used as a landmark by ships sailing the strait between the Indian Ocean and the South China Sea. Then, over the course of about 20 hours on August 26th and 27th, that mountain detonated in a series of explosions so powerful that the fourth and final blast is still considered one of the loudest sounds ever recorded in human history. People over 2,000 miles away, in what is now Perth, Australia, reported hearing it as a distant cannon fire. That changed fast. To put that number in context, 2,000 miles is roughly the distance from New York City to Los Angeles. Imagine a single sound loud enough that someone on the opposite coast of the United States could hear it. The pressure wave from that final explosion circled the entire planet multiple times, registering on barometers as far away as London. But the sound was not what killed people. The collapse of the volcano into the sea generated a series of tsunamis, some estimated at over 30 meters high, that slammed into the coastlines of Java and Sumatra. Official records from the era put the death toll above 36,000 people, almost all of them from drowning, not from lava or ash. Scientists generally do not conclude that a single number like that can ever be fully precise for an event that old, but even the most conservative modern estimates place it among the deadliest volcanic disasters ever documented. The effects did not stop at the shoreline. The explosion injected so much ash and sulfur dioxide into the upper atmosphere that sunsets around the entire planet turned vivid shades of red and orange for months afterward, a phenomenon documented by newspapers and artists as far away as London and New York. Average global temperatures dipped measurably in the following year, a cooling effect scientists now understand as a signature of major volcanic eruptions injecting reflective particles high enough to circle the globe. To put that in context, a single volcanic event on one small island in Indonesia altered sunsets and average temperatures on a planetary scale. That is the baseline this entire story gets measured against. If you follow natural disaster news at all, that name probably already rings a bell. Krakatoa is not a rare historical footnote. It's a permanent reference point, the disaster other disasters get measured against. And that is exactly why what happened next matters so much. For 44 years after the 1883 collapse, the caldera left behind sat quiet, a drowned crater beneath the waves. Then, in 1927, something started rising. Fishermen and local residents reported steam and small explosions breaking the surface of the water. Over the following months, a new island began to build itself out of the same vent system that had destroyed the original mountain. Indonesian geologists gave it a name that translates roughly to Child of Krakatoa, and the name stuck. Anak Krakatau has been growing almost continuously ever since. By some estimates, in the decades since it broke the surface, the cone has added several meters of new material most years, occasionally more, occasionally less, depending on how active the underlying magma system happens to be at any given time. Here's the part that makes this different from most of the disaster stories we cover on this channel. Anak Krakatau is not a sleeping giant that occasionally twitches. It is one of the most persistently active volcanoes on the entire Indonesian archipelago, which is itself the most volcanically active country on Earth. Indonesia sits directly on the Ring of Fire, the horseshoe-shaped chain of fault lines and subduction zones that wraps around the Pacific Basin, and is responsible for the overwhelming majority of the world's earthquakes and eruptions. According to the Global Volcanism Program, Indonesia has recorded eruptions at more volcanoes than any other country since the 1960s, well ahead of Japan and the United States. When Indonesian monitoring agencies say a volcano's alert level has changed, it is not a casual observation. It's the output of a dense seismic network built specifically because this country cannot afford to guess wrong. The growth itself has been documented in fits and starts rather than one smooth climb. Researchers tracking the cone through the 20th century recorded periods where it added several meters of height in a single active year, followed by quieter stretches where growth slowed to almost nothing. Some of those active phases were dramatic enough to be witnessed directly by scientists studying the island, who described near-continuous small explosions building the cone layer by layer, almost like watching, in fast motion, the same process that built the original mountain over thousands of years. To put that in context, geologists are essentially watching a volcano rebuild itself in real time, on a human timescale rather than a geological one, which is part of why this particular island has become one of the most closely studied young volcanoes on the planet. But here's the part nobody outside Indonesia really talks about. Anak Krakatau does not just erupt occasionally like a typical stratovolcano. Because it sits on a young, unstable cone built directly on top of a collapsed caldera, its flanks are structurally weak. And weak flanks on an island volcano are, historically, exactly the kind of feature that produces the deadliest secondary hazard in volcanology, the flank collapse tsunami. That risk stopped being theoretical on December 22nd, 2018. Late that evening, without the kind of dramatic, days-long warning signature that usually precedes a major eruption, a large section of Anak Krakatau's southwest flank slid into the Sunda Strait. Investigators later determined the volcano had lost roughly 2/3 of its above water volume in that single collapse. The landslide displaced an enormous volume of seawater, generating a tsunami that struck the coastlines of Java and Sumatra with almost no warning at all, because the trigger wasn't a traditional tectonic earthquake, which is what most regional tsunami warning systems were built to detect. Official death tolls from that event were placed above 400 people, with thousands more injured and tens of thousands displaced. Scientists studying the event afterward noted that the volcano had shown months of elevated activity beforehand, but the specific timing and mechanism of the final collapse were not something existing monitoring systems were designed to catch. No filler, no guessing, just the facts and the full picture. Post-event analysis using satellite radar imaging showed the cone's height had actually dropped by more than 100 meters in that single night, visible proof of just how much material slid into the sea in a matter of minutes. Coastal residents on Java and Sumatra reported waves arriving within roughly 20 to 30 minutes of the collapse, in some locations without any siren, alert, or official warning at all, because the automated systems in place were tuned to detect the seismic signature of tectonic earthquakes, not the specific rumble of a volcanic landslide. That gap between what the technology was built to catch and what actually happened is now treated as one of the defining case studies in modern tsunami warning design. That changed fast. In the years since 2018, Indonesian authorities have invested heavily in expanded seismic, thermal, and satellite monitoring specifically around Anak Krakatau, precisely because the 2018 event exposed a blind spot in the region's early warning systems. New instruments now include tilt meters that measure microscopic changes in the ground's angle as magma shifts beneath the surface, continuous gas emission sensors that track sulfur dioxide output as a proxy for rising magma, and satellite-based radar interferometry capable of detecting ground deformation of just a few centimeters from orbit. There is currently no scientific evidence that a repeat collapse of the same scale is imminent. But there is also no scientific evidence that it can't happen again, and that uncertainty is exactly why every fresh signal out of that volcano gets treated with this much seriousness. Keep an eye on flank stability, too. It's one of the quieter numbers in this story, but it may end up being the one that matters most. Which brings us to what is happening right now. In early July of 2026, Indonesia's volcanology agency raised Anak Krakatau's alert status from level 2 to level 3, the second highest tier on the country's 4-level scale, citing a measurable surge in volcanic activity and evidence of magma movement toward the surface. Officials described increased seismicity and confirmed the volcano continuing to produce ash-bearing eruptive plumes, with reports of explosions sending material roughly 100 meters above the crater and authorities maintaining an exclusion zone around the island itself. This was not an isolated blip. Monitoring through the spring and summer of 2026 had already tracked a gradual escalation in unrest across the volcano, building toward this alert level change rather than appearing out of nowhere. To put the mechanics of that escalation in context, when volcanologists talk about magma moving toward the surface, they are describing a specific, measurable process. As molten rock forces its way upward through cracks in the crust, it generates small, repetitive earthquakes known as volcanic tremor, distinct from the sharp single jolts of tectonic quakes. At the same time, The rising magma releases dissolved gases, mainly sulfur dioxide, which seep out through the surface in increasing volumes days or weeks before eruptive activity intensifies. Indonesian monitoring teams track both signals continuously, and it was a combination of rising tremor counts and elevated gas readings, alongside the deformation data pulled from satellite radar passes, that collectively justified the jump from level 2 to level 3 this July. No filler, no guessing, just the facts and the full picture. A level 3 alert in the Indonesian system means sustained volcanic unrest with an elevated probability of further eruptive activity, but it is explicitly not the same as a confirmed imminent major eruption. Scientists generally do not conclude that an alert level increase guarantees any specific outcome or timeline. What it does mean is that the underlying magma system is behaving differently than it was during the preceding quieter period, and that the agencies responsible for tens of thousands of coastal residents have decided the risk profile has changed enough to act on publicly. The difference between a routine eruption at Anak Krakatau and a genuinely catastrophic one is not luck. It is structural. Small, frequent, explosive eruptions, the kind this volcano produces almost continuously, are part of how the cone maintains itself. The danger scenario Indonesian scientists actually worry about is a repeat of the 2018 mechanism. A sudden, large-scale flank failure driven by a rapid pulse of magma intrusion, destabilizing an already fragile structure. That is a fundamentally different and far rarer event than the ash plumes making headlines this month, and distinguishing between the two is exactly the kind of nuance that gets lost the moment a story like this goes viral. So what would the worst-case version of this actually look like? Based on the 2018 event, scientists model the highest risk scenario as a large flank section failing suddenly, displacing enough seawater to generate a tsunami that could reach the nearest populated coastlines of Java and Sumatra in under 30 minutes, faster than most evacuation routes are designed to clear a beachfront community. That is why the current exclusion zone around the island exists, why coastal districts near the strait have run tsunami evacuation drills in recent years, and why the expanded monitoring network built after 2018 is specifically designed to shrink that warning gap, even if it can never fully close it. Scientists cannot accurately predict whether this July's unrest will ever reach that threshold. Most level 3 episodes at this volcano do not, but the infrastructure now in place exists precisely because, in 2018, nobody had time to find out in advance. To put the current situation in a wider context, Anak Krakatau is not erupting in isolation, and that regional pattern is part of why 2026 has been such an active year across the archipelago. Just months earlier, Indonesia's global volcanism program contacts recorded 9 actively erupting volcanoes across the country at once, one of the highest simultaneous counts in recent memory. Mount Dukono, on Halmahera Island, has been in a state of near-continuous eruption since 1933, 93 consecutive years and counting, and turned deadly again this year when volcanic bombs and ash killed 3 hikers who had climbed despite an official ban put in place weeks earlier. In the days following that tragedy, monitoring teams recorded an average of over 50 eruptive events per day, with ash plumes repeatedly climbing thousands of meters above the summit and satellite instruments detecting thermal anomalies and sulfur dioxide emissions from orbit. Mount Semeru in East Java logged well over 200 recorded eruptions in the opening weeks of the year alone, with authorities warning residents to avoid activity within 13 kilometers of the crater in the most exposed sector, and up to 17 kilometers along drainage channels where hot volcanic material and lava flows can travel. And it isn't confined to Indonesia. Across the wider Ring of Fire, the Philippines' Mount Mayon was pushed to its own elevated alert level this year after a sustained run of rockfalls, numbering in the hundreds, and continuous lava emission from its summit, a combination officials described as evidence that magma was actively ascending beneath the surface at an accelerating rate. Tal Volcano near Manila, meanwhile, has continued releasing well over 1,000 tons of sulfur dioxide a day, even while sitting at a comparatively low alert tier. A reminder that a quiet-looking alert level does not always mean a quiet volcano. If you follow this region at all, that pattern probably already rings a bell. Southeast Asia's volcanoes do not operate as isolated stories. They sit on connected, overlapping fault systems and subduction zones, and a genuinely active year tends to show up as a cluster of simultaneously restless mountains rather than a single outlier. That does not mean one volcano's activity is scientifically causing another's, and no credible agency is claiming that it is. But it does mean the monitoring agencies across the region are, right now, unusually busy at the same time, watching more of these systems more closely than they have in years. To put that regional workload in context, Indonesia alone recorded well over 1,000 individual volcanic eruption events across its archipelago in 2026, according to national monitoring data, a figure that reflects both a genuinely active year and a monitoring network sensitive enough to catch far more activity than it could have detected a generation ago. That improved sensitivity is, in a strange way, part of why 2026 feels like such an unusually loud year for volcanic news. Scientists are not just watching more eruptions happen. They are watching more eruptions than ever before, because the tools finally exist to see them clearly. None of this is happening in a vacuum of unprepared communities. Coastal districts along the Sunda Strait have run tsunami evacuation drills in recent years, specifically built around the lessons of 2018, teaching residents to recognize sudden, unexplained changes in sea level or a distant rumble as a reason to move to higher ground immediately without waiting for an official siren that a volcanic landslide might outrun. Fishing communities on both the Java and Sumatra sides of the strait have adjusted informal practices too, with many boat operators now avoiding overnight anchorage close to the island whenever the alert level rises, choosing instead to pull vessels further up the shore than they otherwise would. Tour operators who once ran boat trips out to view the volcano up close have scaled those excursions back or suspended them entirely during elevated alert periods, a direct response to the exclusion zone Indonesian authorities maintain around the island at level 3 and above. To put the human stakes in context, the coastlines flanking the Sunda Strait are home to dense fishing and farming communities, along with growing tourism infrastructure catering to both domestic Indonesian travelers and international visitors drawn to the region's beaches and volcanic scenery. A significant tsunami event reaching those shores within the 20 to 30-minute window seen in 2018 would give emergency services almost no time to coordinate a large-scale response, which is exactly why the burden has shifted toward automatic, instrument-triggered warnings rather than relying on human observation alone. Newer systems combine seismic tremor detection with rapid sea-level sensors positioned closer to the island than existing infrastructure could manage a decade ago, cutting the theoretical warning time even if it can never be stretched to zero risk. Keep an eye on official bulletins over the coming weeks, too. Indonesia's volcanology agency publishes daily updates on Anak Krakatau's seismicity, visual observations, and alert status, and those bulletins are the single most reliable way to track whether this July's unrest is settling back down or continuing to build. Sudden jumps in daily earthquake counts, a shift from ash-only explosions to visible incandescent material at night, or any report of harmonic tremor, a specific continuous seismic signal associated with sustained magma movement, would all be considered significant escalations by the scientists watching this volcano professionally. So what actually comes next? In the near term, expect continued small to moderate ash eruptions from Anak Krakatau, continued exclusion zone enforcement around the island, and continued daily bulletins from Indonesian volcanologists tracking seismicity and gas output. Alert level 3 can persist for weeks or months without escalating further, and it can also, in rarer cases, be a step towards something larger. Scientists cannot accurately predict the exact timing or scale of the next major event at any active volcano, and Anak Krakatau is no exception. What they can do, and what this current alert change represents, is respond to real-time data with real caution, adjusting exclusion zones and public warnings as the underlying signals shift. The difference between this story fading quietly off the news cycle in a few weeks and this story becoming the next major headline out of Southeast Asia comes down to a small set of measurable signals: tremor counts, gas output, ground deformation, and flank stability. None of those numbers are secret. Indonesian and international monitoring agencies publish them continuously, precisely so that residents, scientists, and yes, channels like this one are all working from the same real data instead of speculation. That is the story of a volcano that was born out of the deadliest eruption in recorded history, rebuilt itself for nearly a century, proved in 2018 that it could still kill hundreds of people with almost no warning, and is, as of this month, giving scientists enough reason to move it back up the alert scale. No guessing, no dramatizing, just the facts, the science, and the real stakes. If you want to be the first to know the moment something like this escalates anywhere on Earth, subscribe, hit that like button, and turn on notifications, because this is exactly the kind of story that can change within days, not months. Let us go. See you in the next one.